8th graders, today's lesson is 2.4 Thermal Energy MiniLab. So it has 3 different parts to it that you guys will be kind of all centering around the same 2 focal points, which are your learning targets for today. So the first one is I can model the kinetic energy of an object at different temperatures. So what you guys are going to do to start off is you guys are going to look at a glass of hot water and a glass of cold water. Obviously we know that the hot water has a higher temperature, the cold water has a colder temperature. You guys will get that temperature and see what that actually looks like if we were to equate that. Over the last couple days, we've talked a lot about what temperature actually is, and it's not the ability to feel hot and cold. Temperature is actually the amount of kinetic energy that an object has, so the average amount of kinetic energy. And again, this is why we studied averages a couple weeks back. Okay, so again, looking at what temperature is when we're taking a temperature now, we can kind of look at that in a different light, as in how much kinetic energy does this object have versus just is it hot or is it cold, okay? And then their second learning target is I can model how energy transfers between 2 objects. So we're going to kind of start shifting our lesson focus into energy transfers now. If we put 2 objects together or if 2 objects come into contact, what does that look like as far as energy transfer? Okay, I know we talked a lot when we did the thermal energy demos about the fact that when 2 objects come into contact, the hotter object's transferring energy to the colder object. Okay, and that's what we actually feel when we feel temperature. We feel energy transfers, heat transfers. So if we're losing energy, we'll feel cold, and if we're gaining energy, we'll feel that something's hot. Okay, so you guys will be able to model those energy transfers. All right, so let's take a look at part 1. Part 1's a little mini lab for you guys, and those of you guys who are at home, you have little separate videos to watch that'll help you guys collect this data. So what we did in class is we had 2 cups, one that was labeled hot and one that was labeled cold. You guys will see beakers in yours so you can see the volumes that I used. Obviously in the hot one, we're going to fill up equal volumes of hot water, and then in the cold one, we're going to do cold water, and then we get a temperature of those. Okay, so obviously the kids in class are doing this. You guys at home are going to right-click this little video down here, open your link up, and you guys should see a video that looks like this. Okay, so watch that. It's pretty short. Collect your guys' data to add into your temperature, so you guys can go ahead and pause that this video and do that now. All right, so welcome back. Moving on to the second part of this. So what you guys have saw and what you guys will model here in a second is what a glass of hot water looks like or hot object looks like versus what a cold object looks like. Okay, on this second part of our mini lab, you guys are going to mix those 2 volumes. So you have equal volumes of hot and equal volumes of cold. What do you guys think would happen if we were to mix those? So this first question asks you, predict what you think will happen if these 2 equal volumes of hot and cold water are mixed. So write your answer there, and then you guys can go ahead and move on and get your answer to that. So you guys can right-click this video here. Oops. Right-click it, open the link, and then you guys should see this video right here. Okay, with the hot and the cold, we're getting ready to mix those. So now mix the 2 cups of water, swirl slightly for a few seconds, and let the water sit for about a minute to let it reach equilibrium. Equilibrium's where basically all the molecules have finished transferring energy, so now they have all the exact same amount of energy. What happened? Use your thermometer, okay? So you guys again can watch this little video here, take a second to pause, and then come back with these 2 answers. All right, welcome back. You guys should have an answer here and an answer here, so you guys should have saw that after about a minute what happened to your temperature. All right, last set of questions. Before being mixed, which cup had more kinetic energy? And again, this is something you're going to be modeling here in a second. And then what do you think happened to the kinetic energy of the hotter molecules in the hotter cup when the 2 molecules are mixed? So when we took all those little hot molecules in the hot cup and poured them in with the cold molecules, what do you guys think happened to the kinetic energy that those hot molecules had? Okay, so explain where you guys think that went, how it might have looked. All right, so now we're going to actually say that we're scientists that can zoom in and look at a molecule and see energy. Okay, so what we're going to be doing in this part is modeling what that might look like to someone who maybe doesn't understand what temperature really is or what that would look like in molecules. So you've been given 2 pieces of paper and 32 cubes. You guys will see that slide 6 is actually your guys' 2 pieces of paper and cubes. The 2 pieces of paper represent 2 different objects, each with 4 different molecules. So you'll see a total of 8 molecules, 4 in object 1, 4 in object 2. The yellow cubes represent energy. You guys have little yellow squares that you'll be able to click and move. One individual cube represents exactly 1 kilojoule of kinetic energy. So 1 cube is 1 kilojoule. So if I have a molecule that has 8 little cubes in it, its energy is 8 kilojoules. So, you know, the higher the kinetic energy is, the faster those little molecules would be moving. Okay, lay the 2 pieces of paper side by side with object 1 on the left. Object 1 will represent the hotter object, and object 2 will represent the cooler of the 2. You need to use all 32 cubes to represent object 1 being hotter and object 2 being cooler. All molecules in the same object must have equal amounts of kinetic energy. For instance, if one molecule in object A has 6 kilojoules of energy, then the other 3 molecules must also have 6 cubes. Distribute the yellow cubes accordingly. All right, so let's take a look at what this actually looks like. You guys can see on the left here we have object 1, and on the right here we have object 2. So this is our colder object, it has 4 molecules. And this is our hotter object, object 1, and it has 4 molecules as well. These little yellow squares right here are your energy cubes. Okay, and they can be clicked and moved to different spots on this slide. Okay, you need to use all 32 of these energy cubes, okay? My suggestion to you guys is, first off, you can remember that one of these little cubes represents 1 kilojoule of energy. So by adding this little block right here, this molecule has 1 kilojoule in it of energy, okay? But because this is one object right here made up of 4 molecules, I would also need an equal amount of energy in those other 4 molecules, or 3 molecules as well. Okay, my suggestion to you guys is, obviously this is your hotter molecule, so should that have more or less kinetic energy? Okay, my suggestion to you guys would be kind of to do a you get one, you get one, you get one, you get one method, because remember, you have to use all of these cubes, and each of these molecules in each object need to have the same amount. So if you end up putting 6 total cubes in this one molecule on object 1, the other 3 molecules in this object need to also have 6, okay? With that being said, you need to make sure you have enough for this one as well. So if you're going to put 6 here, I would also do, you know, one at a time. You get one, you get one, you get one, you get one, okay? Again, remember, this is your hotter object, so think of how much kinetic energy it needs to have compared to this colder object. And again, each molecule has to have the same amount. And finally, make sure you use all 32 cubes. They should distribute evenly once you guys kind of figure this out and move them around accordingly. Okay? All right, moving on to your questions. Describe how you arranged your cubes and the 4 different molecules of each object. So tell me how many little yellow cubes you used in each molecule on object 1, and tell me how many you used on object 2. So, you know, you might say, you know, on object 1 I used 10 molecules, 10 energy cubes on each molecule. So there would be a total of 40 for that whole object, okay? Or on average 10 per molecule. And then how many did you use on object 2? Oh, I used 1 on each molecule on object 2. Okay, so there was a total of 4 that you used for object 2. How much kinetic energy does each molecule in object A have? So remember, 1 energy cube equals 1 kilojoule of energy. So use that to kind of help you guys decide the answer to that question. How much kinetic energy does each molecule have in object B? Same question, different object. And then finally, if object A and B come into contact, what do you think will happen to the kinetic energy of the object? So what do you think would happen to the kinetic energy of A? And what do you think would happen to the kinetic energy of B if those 2 objects came into contact and we were allowed to transfer energy? All right. Part 3 gets us started into this concept of energy transfer. Again, we kind of talked about, if you feel something cold, it's because you're losing energy, okay? If you touch something that's hot, you're gaining energy from that object. Okay, so it feels hot because you're getting energy. It feels cold because you're losing energy. Okay, so what you guys are going to do is you guys are going to push the 2 objects together. So what you're going to do is you're going to go back to slide 6. You guys have equally distributed those little energy cubes between the hot object, which should have more, and the cold object, which should have less. Okay, so you guys are going to push those 2 objects together. If you guys want, you guys can actually click and drag and move those pictures. Those little yellow cubes won't necessarily move with the circles. But you can do that, or you guys can just imagine what would happen if those two were in contact. Okay, then you guys are going to move the energy cubes around appropriately until all the molecules have the same amount of kinetic energy. So now it's kind of like when the two objects are touching, it's almost like we have one object now that has 8 molecules instead of 4 each. Okay, so now you're going to kind of redistribute all those little yellow squares until all 8 of those molecules have the same number of yellow squares with the same amount of kinetic energy. Okay, all 8 molecules will have the same number of yellow squares. Pay attention to how you are moving the squares. So think about from what object to what object are you guys kind of moving those to distribute them equally. Okay, finally, answer this last question. Look back at the questions you just answered with the energy cubes. Based on what you observe as far as the transfer of kinetic energy, if we hold an ice cube in our hand, are we warming up the ice cube, or is the ice cube cooling down our hand? Okay, so think about that. It's really only one thing. So are we warming up the ice cube, or is the ice cube cooling down our hand? So tell me what you guys think. Either we're warming it up or we're cooling it. The ice cube's cooling our hand down. And then give me an explanation as to why you think that is. Okay, finally, do your wrap up. Do you have any questions? Use the draw tool to circle yes or no. If you have questions, type them right here. Obviously, if it's something preventing you from completing this assignment, let me know. And then finally, how do you think you did on this assignment? 4, 3, 2, 1. Nice work. Go ahead and hand this in. I hope you guys are all having a great Friday.